Hi, in today's video we're going to have a sneak peek at the most recent mechanics exam from Cambridge. The actual exam was only last week, so there is no mark scheme available for this exam, and I'm just only showing the way I would approach this exam if I was a student. So if I make any mistakes along the way, please let me know in the comments to the video, and let's have a look at the first question. Okay, question 1 is about work and energy, and I will start by drawing the diagram. We got 2 points A and B. The distance between those 2 points is 50 meters. Velocity at A is 0. Velocity at B is 6. And there's a bicycle. There's a driving force. And there's also the force of resistance. Now we also know that the driving force equals to 100 newtons. And we know that the work done against resistance is 3,560 joules. Okay, so first of all, if there is a driving force, that means this driving force is doing some work. And that work equals to force itself, 100 newtons, times the distance, 50. So that is 5,000 joules. And this work is being converted into the work done against resistance, and also into the increase of kinetic energy. So now we can write the equation. 5,000, that's my work done by the driving force, equals to 3,560, that's the work done against the resistance, and the rest goes to increase the kinetic energy. So kinetic energy at point A is 0, because velocity is 0, and then kinetic energy at point B is going to be m, the one we're looking for, times v squared, 36, over 2. And now from here we can find the mass. I'm going to divide 36 by 2, get 18, and then rearrange this equation to get the mass. So 18m equals to 1,440. Now divide by 18, and we will get 80 kilograms. That's going to be my final answer for question 1. Okay, question 2. Again, we're going to start by drawing the diagram. Here's an inclined plane. The angle is 30 degrees. Here's the particle, and the mass is 0.4 kilograms, therefore the weight 0.4 times 10, 4 newtons. And there's also force of friction. So now the particle is trying to slide down the plane, and the force of friction is preventing this motion. So that means the force of friction is acting upwards. Okay, now it's time to choose x and y axis and write down the second Newton's law. I will choose x-axis to point upwards, and the y-axis is going to be perpendicular. Starting with x-axis, we got a force of friction minus, I will have to find the x component of the weight. This little angle here is 30 degrees, and the x component of the weight is opposite of that angle. So that means I'll have to multiply 4 by sine 30. Now remember that's the equilibrium, so that means the sum of forces equals to 0. Now on y-axis, we've got the normal reaction minus the y component of the weight, which is adjacent to the angle of 30. So that means I'm going to multiply 4 by cosine 30. And that also equals to 0. So from here, I can find the normal reaction. Then I will multiply it by the coefficient of friction, mu, and I will get the force of friction. So it's 4 mu times cosine 30. Now I will substitute this into the first equation. So I will get 4 mu cosine 30 minus 4 sine 30 equals to 0 divided by 4. And then move sine 30 to the other side. Now divide both sides by cosine, and then sine over cosine is going to be tangent. So mu equals to tan 30, and it is actually square root of 3 over 3, which is exactly what we had to show. Okay, now in question B, we're going to apply the force 7.2 newtons directly up, and then we have to find the time that the particle P takes to move 1 meter. So first I'm going to find the acceleration by writing the second Newton's law on x-axis. So 7.2 is along the x-axis, take it with a plus sign, minus force of friction. And also don't forget the x component of the weight. So the weight is 4 newtons, and the x component would be opposite of the angle, so it will be minus 4 sine 30. And that equals to ma, which is 0.4, times acceleration. Now for y-axis, we've got our normal force, minus 4 cosine 30 equals to 0. So the normal force is 4 cosine 30. And we can use it to find the force of friction, because now we already know the coefficient of friction, that's square root of 3 over 3. Then multiply by 4 cosine 30. When I calculate it, it equals to 2. So now let's substitute this back into the original equation. Then we'll get 7.2 minus 2 minus 4 times sine 30 is 2. So got 0.4a. Now on the left side, we've got 3.2 equals to 0.4a. So therefore a equals to 8. Okay, and now we can use the Seward equation to find time. We know that distance equals to u times t plus at squared over 2. We start from rest, so u equals to 0, s is 1. We know a is 8, t squared over 2. So it means 4t squared equals to 1. T would be t squared is 1 over 4. Therefore, t equals to 0.5. Okay, here's the answer. 0.5 seconds. Okay, next question, equilibrium. And first, let's draw all the forces. So the mass of the particle is 0.3, so therefore its weight is going to be 3 newtons downwards. The force of tension is 4 newtons, and we're looking for this force of tension, an angle alpha. To start with, it's always a good idea to draw x and y axis. I will choose y to be vertically up, and x is going to be, of course, perpendicular to y. And next, I will write the second Newton's law, the sum of forces equals to ma, or in this case 0, on x and y axis. Start with x-axis. So first looks at the force t, that angle here is alpha as well. And the x component is opposite of the angle alpha. So that means I'll have to multiply by sine alpha. So I got t sine alpha. Moving on to the force of 4 newtons. This angle here is 60. And the x component is adjacent to the angle of 60. So it's minus 4 cosine 60. That equals to 0. Now on y-axis, the y component of 4 newtons is opposite of the angle of 60. So it's going to be 4 sine 60. Now the tension on y-axis acts downwards. So it's going to be minus t. And also y component of t is adjacent to angle alpha, so it's going to be minus t cosine alpha. And don't forget we also have the weight of the object, which is 3 newtons. So minus 3, because it's in the opposite direction of my y-axis. Okay, so now we have simultaneous equations, and we'll have to solve it for t and alpha. Okay, now to solve this equation, I'm first going to move 4 cosine 60 to the other side. And then I will also move t cosine alpha to the right side. Now I'm going to divide this equation. Left side by the left side and right side by the right side. So t will cancel out, and sine alpha over cosine alpha is going to be tangent alpha. Now all we have to do is to take the inverse tangent of this fraction. And I got 76.94. And next we can substitute this value into, let's say, the first equation to find t. So t sine 76.94 equals to 4 cosine 60. Divide by sine 76.94 and we'll get it. That equals 2.05. So tension equals to 2.05 newtons. And the angle equals to 76.94 degrees. Okay, next question is about the power, and I will again start by drawing the diagram, although it might be unnecessary in that case. Got the road AB, the car. The mass is 1,200 kilograms. That's a resistance force. And the velocity at A equals to 15 meters per second. Acceleration is 0.8. And we're looking for the power. Now, if you look at this diagram, there is one force missing. That's the driving force of the car. And if we're looking for the power, we can use the formula power equals driving force times velocity. We know the velocity, and all we have to find is the driving force. Now, for that we can use the second Newton's law, the sum of all forces equals to mass times acceleration. So I will do the driving force minus force of resistance equals to ma. We know that the force of resistance is 500 newtons, the mass of the car is 1,200, and acceleration is 0.8. So from here, the driving force would be 1,460. And now I will multiply by the velocity. And that equals to 21,900 watts. Okay, question B. So the engine keeps working at the same power, and the car travels for 53 seconds. Now we have to find the distance between the 2 points A and B. And for that I can use the work and energy principle again. So there's the driving force, which is doing some work, and we can calculate the work done by that force by multiplying power by the time. And we found the power in the previous question. That's 21,900 watts. And it's given that the time is 53 seconds. So the work done is this. 1,160,700 joules. Okay, and the work done is being converted into the work done against the force of resistance, and it also goes to increase the kinetic energy of the car. Now, what is the work against resistance? It is the force of resistance times the distance. And the force of resistance is 500 newtons. The distance is s. That's what we're looking for. Now, what's the increase of kinetic energy? That will be the final energy, which is mv squared over 2. We know that the mass of the car is 1,200. And at point B, the velocity is 32. So that's my mv squared over 2. And I will subtract the initial kinetic energy. We know that at point A, velocity is 15. And now we can make the equation. Work done equals to work against the resistance plus the increase of kinetic energy. Okay, now the increase of kinetic energy is apparently this. Now I'm going to move it to the left side and I will get 500s equals to 681,300. Now divide both sides by 500 and we got 1,362.6. That's exactly what we had to show. Okay, next question is about tension in strings. So first let's draw all the forces. There's no force of friction acting on A, it acts only on B. Now the weight of the block A is 800 newtons. The weight of block B is 400 newtons. Let's also draw x and y axes. And let's start resolving all forces on x-axis. So for the block A, it's going to be 500 cosine 15. No resistance, and for the weight of the block, we need the x component. Now this little angle here is 20, and the x component is opposite of the angle. So it's going to be minus 800 times sine 20. And there is also tension in the string. And all of this equals to ma, which is 80 times A. Now for the block B, tension acts upwards. So we got tension minus 400 sine 20 And there's also force of friction, which equals to 50 newtons, and all of that should be equal to 40 A. Now let's simultaneous equations, so let's add them up. Tension will cancel out, and we'll get this. Now divide all of this by 120 and we'll get A. Now we can substitute it, let's say, into the second equation. And we'll get T equals to 50 plus 400 sine 20 plus 40 times 0.188. That equals to 194.32. Let's round it up to 3 significant figures, so 194 newtons, and acceleration equals to 0.188 meters per second squared. Okay, next question. We know the final velocity, v. We know that we start from rest, so u equals to 0. And we also know acceleration from the previous question, which is 0.188. And we're looking for the time. So we know that acceleration would be a change in velocity, so 1.2 minus initial velocity 0, over time, which we're looking for, and that should be equal to 0.188. Now multiply both sides by t. And then from here we can find t. 6.38. Okay, question 6 is about momentum conservation. We've got the particle with a mass of 0.3. And before the collision, it was moving with velocity 2 meters per second, so times 2 to find the momentum. And then after collision, its velocity reduced to 0.6. And then also plus the mass of the second particle times its velocity. Now from here we can find v. So I got 0.4 v equals to 0.42. And from here, v equals to 1.05. Which is exactly what we had to show. And let's move on to part B. Now the particle B with a mass 0.4 and velocity 1.05 was moving towards the particle C with a mass m. And then after the collision, they stick together, so they make one particle with a mass m plus 0.4 and a combined velocity of 0.5. So now we have to find m. Again, momentum conservation. Before the collision, 0.4 times 1.05, and its particle was stationary, so 0. Now that equals to new mass m plus 0.4 times the velocity 0.5. Now let's solve it, and we got 0.42 equals to 0.4 m plus 0.2. So therefore 0.5 m equals to 0.22, and m equals to 0.44. Alright, for the part C, we'll have to draw a couple of diagrams to understand better what's going on. We know that initially, the distance between particle B and the particle C used to be 2.1 meters. And it is still the same right after particle A collides with the particle B. But then what happens next is the particle B starts moving with velocity 1.05, And then particle A continues motion with the velocity 0.6 meter per second. Now, what happens when particle B collides with C? So for this to happen, particle B has to travel 2.1 meter, and the time for that would be 2.1 distance over velocity, which is 1.05, and that will be 2 seconds. So that's the time for B to reach C. Meanwhile, during this time, particle A will travel 0.6 times 2, which is 1.2 meters. So that means when particle B and C collide, if particle A travels 1.2 meters, so that means it's going to be 2.1 minus 1.2 meters away from the collision of B and C. And that distance equals to 0.9. Okay, and now that's where we start the time. Because we're looking for the time from the instant when B and C collide. So at this point, t equals to 0. Now, let's say that the position of A when particle B and C collide is going to be the origin, so it's 0. Now, the x-coordinate of A, and I will say that the x-axis is pointing to the right, so the x-coordinate of A would be velocity of A, still 0.6, times time. Meanwhile, the coordinate of combined particle B and C would be 0.9. That's the distance from the origin at the moment when they collide, plus their combined velocity, which is 0.5, as given in the previous question, t. Now, when particle A collides again, that means the x-coordinate of A is going to be equal to the x-coordinate of B and C. So we can make an equation, 0.6t equals to 0.9 plus 0.5t. And from here we can find t. 9 seconds. Okay, next question, we're supposed to find velocity and we're given acceleration, so that means we can integrate acceleration. So it's going to be the integral of 0.3 t to the power of 1 over 2 dt. So 0.3, increase the power by 1, so it's 3 over 2, and then divide by 3 over 2, which is the same as multiplying by the reciprocal. Then don't forget plus c. So all in all, we got 0.2 t to the power 3 over 2 plus c. Now we're given that the particle starts from rest, so it means when t equals to 0, velocity is also 0. So when I substitute 0 into my formula for the velocity, I get c, and it must be equal to 0, so that means c equals to 0. Okay, now find the velocity of p at t equals to 4. Let's substitute 4. And we'll get 1.6. Okay, next question. Now there is no change in velocity of p at t equals to 4. So now we'll have to find the velocity using the second formula. And it's going to be minus integral of k t to the power of minus 3 over 2 dt. Again, add 1 to the power. Minus 3 over 2 plus 1 is going to be minus 1 over 2. Divide by minus 1 over 2, which is the same as multiplying by minus 2. So all in all, we got plus 2. K times t to the power of minus 1 over 2, and of course, don't forget plus c. Now we're given that velocity doesn't change when t equals to 4. So I will substitute 4 into the formula for the velocity, and I will get 2k, 4 to the power of minus 1 over 2, plus c, and that must be equal to 1.6, because the velocity doesn't change. Now simplify that a little bit, and we'll get k plus c equals to 1.6. And that's going to be one of the simultaneous equations. So now we are also given that when t equals to 16, velocity is 0.3. So let's substitute 16 into our formula. That's 2k times 16 to the power of minus 1 over 2 plus c, and that must be equal to 0.3. Now, if we simplify that, we'll get 1 over 2k plus c equals to 0.3. Now let's add up the first equation, k plus c equals to 1.6, and we're ready to solve simultaneous equations. I will subtract first equation from the second one, so I'll get a half k equals to 1.3. Now multiply both sides by 2 and we'll get 2.6. Woohoo, we got it. Now we'll have to find c, and we know that k plus c equals to 1.6. So 2.6 plus c equals to 1.6. So from here, c equals to minus 1. And we're also looking for the formula for the velocity. That will be v equals to 2k, and now we know that k equals to 2.6. T to the power of minus a half minus 1. And then finally, v equals to 5.2 t to the power of minus 1 over 2 minus a half, or minus 1. That's the expression for the velocity. Now we're given that p comes to instantaneous rest at t equals to t. So that means v, when t equals to big T, equals to 0. Okay, now let's solve the resulting equation, 5.2 t to the power of minus a half minus 1 equals to 0. Rearrange it. So t to the power of minus 1 over 2 equals to 5 over 26. But now what is t to the power of minus a half? It's 1 divided by square root of t. Flip both sides over. And then square. So we get t equals to 27.04. And finally, the last question, we'll have to find the total distance traveled between 0 and t equals to t, which is actually 27.04. Okay, now how do we find the distance if we know the formula for the velocity? We'll have to integrate it. So our first formula for the velocity is here. It's 0.2 t to the power of 3 over 2. So we'll have to integrate from 0 to 4, 0.2 t to the power of 3 over 2 dt. And plus, we'll have to integrate the second expression from 4 to 27.04. And that expression is above. As we have seen, it's this one in the frame. 5.2 t to the power of minus 1 over 2 minus 1 dt. Okay, the first integral is 0.2 t to the power of 3 over 2 plus 1, which is 5 over 2, divided by 5 over 2 means multiplying by the reciprocal. And that's from 0 to 4. Okay, plus the second integral. 5.2 t, add 1 to minus a half, and we'll get positive half. Dividing by 1 over 2 would be the same as multiplying by 2. Minus integral of 1 is going to be just t, and all of that from 4 to 27.04. Okay, now substitute 4 to the first expression, and we will get 2.56. Now substitute the upper limit to 5.2 times 2 and so on and so forth, and we will get 27.04 minus substitute 4 into that expression, and we will get 16.8. Now altogether, that equals to 12.8. And that's the answer for this question. Okay, and that was the last question of the paper. Again, the mark scheme is not available yet for this paper. In fact, the actual paper is not available. So this video was, again, just only for those who took the exam and want to have a bit of a discussion. So if you have any comments or if you'd like to share your opinion about this particular paper, please let me know in the comments, and I will see you next time. Bye-bye.